Before we start anything, let's recall one of the basic equations of integration and some differentiation equations. In the integral, if we have differentiation of the denominator value in the numerator, then we can write it as ln modulus denominator. So, integral f dash x over fx value we can write as ln modulus fx. The differentiation of Secx equals Secx tan x, and the differentiation of the tan x equals sec squared x. Sounds good. Let's jump into the question. Integral sec x value we can write as integral sec x over 1. Now we can multiply both numerator and denominator value from sec x plus tan x. Then we can remove the brackets in the numerator. Then we have sec squared x plus sec x tan x in the numerator. Denominator we have sec x plus tan x. Let's consider differentiation of the denominator value. Differentiation of the sec x plus tan x value we can write as differentiation of the sec x value equal sec x times tan x plus differentiation of the tan x value equals sec squared x. So in this integral we have differentiation of the denominator value in the numerator. We can write it as ln modulus denominator. So we can get final answer as ln modulus sec x plus tan x.